Hello, this is Maria from mathmammoth.com. In this lesson, we're gonna look at scale drawings and area. Something interesting happens. This triangle, we're gonna enlarge it with a scale factor of 3, and then see in what ratio are the areas of the original and the enlarged triangle. So here's a triangle, and we are gonna enlarge it with a scale factor of 3. That means that this side is 3 units, it becomes 9 units. And the altitude is 4 units, and it becomes 12 units. There we go. The area of this original one is 3 times 4 divided by 2. So 12 divided by 2 is 6 units. I should say 6 square units. And the area of this one, okay, this side was 9 and this side was 12. So the area will be 9 times 12 divided by 2, or the same as 9 times 6, which is 54 square units. So in what ratio are these two areas? Well, we just take the numbers and write the ratio. 6 to 54. That ratio is 6 to 54, which simplifies to 1 to 9. Wow, the triangle was enlarged with the scale factor of 3, and the area became 9-fold. Now, what if we use the scale factor of 2 and make it 2 times as big? Here this side is 3 units, and I will make it 6 units. This side is 4, I'll make it 8. So now what is the area? This is 6 times 8, 48, divided by 2 is 24 square units. And this is 6 square units. So the ratio is 6 to 24, which is 1 to 4. When we doubled the triangle, so to speak, or used the scale factor 2 to enlarge it, then the area quadruples. And this should make sense, because here we take this side, we have to take it 2 times, and we take this side 2 times. So in total, in the calculation of the area, we have the factor of 4. There is a general pattern to this. You may have noticed it. You know, if we used the scale factor of 3, then the areas were in the ratio 1 to 9. And here, if we doubled it, we got the 4 here. So the areas are in the ratio that is a square of the scale factor. Okay, here we again take a triangle and enlarge it with a scale factor of 4 this time. And here's a calculation how to calculate the area of the resulting triangle. Is it correct? We're going to enlarge this triangle with a scale ratio of 4 to 1. And then, to find the area of the resulting triangle, is it correct to multiply 4 times this divided by 2? Now notice this here is the altitude times the base divided by 2. So this here is the area of this triangle. And so it will be in square millimeters. If we take that times 4, is that going to give us the area of the enlarged triangle? The answer is no. Why? Because to calculate the area of the enlarged triangle, we would take 4 times this and 4 times that divided by 2. This is the base multiplied by 4. And this is the altitude multiplied by 4 by the scale factor, and then divide by 2. So, compared to this calculation here, a 4 was missing. This becomes, though, 4 times 4 is 16, and then we have the base times the altitude of the original triangle here divided by 2. So this is the area of this triangle. So again, we take the square of the scale factor to find the area. Scale factor being 4, and now we get to 16 here. Okay, a rectangle is shrunk using the scale factor of 1/2. In what ratio are the areas of the original and the resulting triangles? Try that on your own first. The curious thing about this problem is that it does not tell us the width and the length of the rectangle. It's still possible to solve it though. Let me just sketch something. And it often helps in geometric problems to draw something, draw a sketch. So I'll just imagine that the rectangle is like this. And if it is shrunk using the scale factor of 1/2, then, this is going to be half of the original height, and this is going to be also about half. Kind of like that, right? So would we be able to say anything about the ratio of these two areas? I'm going to draw here a midpoint here, and a midpoint on this side also. If I take half of this side, half of that side, I get a rectangle like that. And that rectangle is exactly 1/4 in area of the original rectangle. Hope you can see that. So we are going to write the ratio of the original and the resulting in that order. So the ratio of the original area and the resulting, it's 4:1. All right, that's all for this lesson. I hope it was helpful.